Okay, I think we'll get started. So this is part 2 of the RS232 communications lab for the LuckFox. Today we're going to actually get away from just the LuckFox talking to itself, and we're going to communicate with a Setra balance which has an old RS232 communication port. This brings up one important idea about RS232, and I won't go into a huge deal. In the last lecture, we mentioned some of the many YouTube channels that talk about these things, or YouTube videos that talk about these things. But generally speaking, you set up a DTE style, which would be the computer, or in this case the LuckFox, and then the devices it's talking to, which in this case would be the balance, is in a DCE form. And that's what's going to happen here. That's the natural setup for the balance. Occasionally, you'll run into a DTE to DTE situation, and then you need something called a null modem to crisscross the TX and the TR, the TX and the RX lines, if you're talking DTE to DTE. So I just mentioned that, but this will set up for direct, very natural. The TX line from the LuckFox will go to the receiving line of the balance, and the TX line of the balance will go to the receiving line of the LuckFox. We're going to display the mass on an OLED. So we'll be reading the mass information from the balance. So the LuckFox will query the balance. The balance will then send the current value of the mass. And then we'll add the feature that we'll be able to send a tear command so that it will tear the balance. Then, just to kind of set an additional stage for this, we'll run a little experiment here. And so, very simple, we'll just look at the mass loss of alcohol swab or alcohol pad as a function of time. And then we'll call back yet another. We have the OLED over here. We'll call back the production using matplotlib to produce a PNG, and then we'll just plot this graph and export the PNG to our local machine and take a look at it. If you're just coming to LuckFox, you haven't gone through our whole series, then the LuckFox tutorial is really good, along with Fusion Automate, which really shows you how to get your LuckFox all set up. Then we did a setup video where we installed extra Python packages. So that's what you're going to need here, both for the OLED and the, well, that's going to be in the I2C video, and then the matplotlib and NumPy and all that will be in the setup video. So you can go back and refer to that if you haven't gotten those Python packages installed yet. Okay, so with that, let's go to the computer. We'll grab the programs, and then we'll take a look at how this all goes. Okay, so we've got things set up here. Now, I'll show you first this. Here's our LuckFox, and this is the same setup we had in part 1. But now, instead of just having the receiving the UART to RS232 go right into the receiving RS232 to UART, we're going to send that to the balance. So that's these two. This is the TX line, and then the RX line coming back from the balance. So let me show you the balance here. So we'll take a look now at the balance. So this is got an RS232 port on the back of the balance. And so we just have an RS232 cable here. And that cable runs to just a breakout board, and we have it's only a 3-pin communication, so it is the black pin is ground, and then TX and RX pins here. These run to ultimately to these green wires here coming into the breadboard. So that's the setup we have. And again, it's being powered by just some 9-volt batteries, just like before. So let's get some programs. These programs, I just had Gemini write them, so they're really good in terms of robust error handling and stuff. I won't go through every step by step, but we'll try to hit the highlights. Okay, so now we're on Google, so let's just search for our page. So darrenolness.com, and we'll go to teaching, LuckFox, and we can scroll our way down here. Let's go to Setra display.txt. This is actually a Python file, also available on GitHub. So we'll copy this. Now go to our terminal. And oops, let me escape here. So I'm going to go sudo nano setra display.py, and we'll paste that in. Okay, again, I had Gemini wrote this, but let's just see what we need here. So we're going to need serial just like we did last time, but we're going to need more of the packages now. We're going to need this Luma package and pill. So if you've been following along with the series, you've already got that on your LuckFox. If not, you want to go back to the I2C tutorial, the I2C lab where we work with the OLEDs. But once that's working, this works great. All right, so here comes the information now. So we'll be talking through our serial port, which is the same as we used last time. But now here's the baud rate, the parity, the number of bits, and so on. Well, where's that coming from? That is coming from, let's see if I've got this here. Okay, so this is the appendix of the Setra manual, and you can enter the user setup mode. And what we notice here is the RS2 communication setup. So we have our choices here. I could have put it at 9600, but it just defaults to 300, so I left it there. On something like a balance where you're not asking it to tell you the, maybe we're going to do 10 times a second, which is really overkill. So 300 baud is plenty fine. You choose the parity, and in this case, we set the parity to none. And then I think there's one stop bit. So then we can go down and look at, let's see, this is all the setup. Okay, here's the RS2 communication. So we're going to use this immediate print. So it'll send this this hashtag, and that will then immediately print back to the TX line of the balance, and that will come into the RX line of our LuckFox. The other command we'll use is T, and that will tear the balance. And let's see, just the interface here. So these are kind of the pins that I was showing when we saw the balance. So pin 2 and 3 are the TX and the RX, and then pin 5 is the ground. So this is just a three-wire communication, which is very typical for RS232. Okay, so let's close that, and then let's continue on with our program here. So this is just a bunch of setup for these queries. So we saw here, this is the hashtag command, so that'll immediately print the mass, and then the tear command will print the we'll tear it. Then there's a carriage return and a line feed to just kind of clear things out. Then just a little bit of time delay so that the communication doesn't get crisscrossed. This is some of the OLED. So we choose a font. You should have this font. It should install with the Ubuntu. So if you're following the setup, if you did the Ubuntu setup that came from the Fusion Animate video, this should all be there. And if it worked in the last lab where we did the OLED, then it should work fine here. Then we just get into just a whole bunch of commands, which I think I'll largely skip. And so basically what this program is going to do then is, as a user, we're going to be able to, it'll continuously display the weight, and then as the user, we'll be able to tear the balance if need be. So let's go ahead and exit this, save it, and let's go ahead and try to run it. So we'll go sudo Python 3. And what we want to be looking for here is if this lights up and starts displaying the value of the scale. And sure enough, we see it. I'll try to bring in a little closer. Hopefully that'll, maybe it will have trouble focusing. Okay. And so this is just recording what it's doing. You can go back into the file and comment this out. This is just showing that it's sending that hashtag to query the weight, and then that's being printed to this device. I'm going to switch over to look at the scale now, just to make sure that we're seeing what we're seeing. So we see the minus 0.007. Let's put something on the scale now, and we see this weight like this. So let's actually put well, let's keep that on there, and then let's tear the balance. So I'm going to go back over here to the desktop, and I'm going to just hit T and enter, and that should tear the balance. And let's go back to the oscilloscope, and now we are 0 and 0. So let me take this off again. -9. I'll leave it on here, but I'm going to hit T for tearing the balance again. And we tear the balance. Okay, so I'm going to quit this. And let's come back to our .cam. Okay. So that is the this just using the balance, talking to the balance. So let's do this actual experiment now. We will do this kinetics experiment. So let's go back to our page here and now grab the kinetics. So copy that and go back to the terminal, and I'll just clear this, and then we'll go sudo nano Setra kinetics.py, and we'll paste in this code. It's the exact same code, but now let me just show. Up top here, we have matplotlib coming in. Oh, do I have the wrong? Oh yeah, okay. Got matplotlib coming in right here. And if you remember from earlier, that's pretty big. That's a pretty big package. NumPy comes in, Matplotlib comes in. So on the LuckFox, it takes a little while. So I put a little print statement here to remind us. It's easy to get impatient and think it's not working. So it does take us a second or two to load. But once it does, basically the same thing is going to show up. But now I'm not going to show the sending the hashtag, but we'll have the option to type an R for record and an S for stop. And during that period of time, that will record our mass. And what we'll do is we'll open up a alcohol prep pad and we'll put that on the balance. So let's go Control X here. Yes. And let's just make sure everything is working. I'm going to back this up just a little bit. Make sure everything working here. So we'll go Python 3. Looks like I probably have a copy error. I'm going to pause and then correct that. Okay, found the error. So let's go and run this. And again, we need to be a bit patient here. So this can take some time. Okay. So should see the display now, should be active. See, getting the right results. So now what we're going to do is I'm going to take this alcohol pad and I'm going to place it on the balance. So let's look at that. So I placed it on the balance, and we're going to record the mass as a function of time. So I'm going to go back to here, and we're going to put record, and it'll start recording. Now I'm going to turn it back to here, I think, so that we can see it. I'll just have it on for a few seconds, then I'll pause the video for maybe 5-10 minutes, and then we'll come back and we should see a different value, obviously, as the alcohol evaporates. And then when we hit stop, I'll go through the process of hitting stop then and send the PNG over to the main machine and look at it. Okay, so it's been going about 10 minutes or so. So let me go back to here, and we will hit stop and stop recording, and then we'll quit. And now we're quit. So I'm going to open up another terminal, and let's I'll go sudo scp, and then here is the evaporation plot. So let's check that. And there it is right there. So that's what was just saved. And so extend this a little bit. So I'm going to send this now to the downloads folder of my main machine here. Okay, and let's see if it's there. So here's downloads, evaporation plot. So let's open that up. And there it is. Still fairly linear here. I'm sure it's, obviously it's going to be eventually kind of curving off here. But quite linear for 10 minutes here, this decay. So this is just one example of what we could do with this once we have this RS232 communication. So again, largely these are no longer used, but there are lots of legacy equipment, such as this perfectly good balance, to communicate. And now the LuckFox can do that and can process it with the power of having the Python. So it gives an example of how you might augment something, some old program with a new program. You could imagine a couple of ways to extend this. One would be to get this completely autonomous and put a push button to tear, a push button to record and to save, and then you could pull the transfer later. You wouldn't have to be controlling everything with the computer. Alternatively, you could set this up in the lab and then SSH in and work with it with the students, say in a classroom. So you could show a remote picture, video of the balance, and you can be talking back and forth with it that way. So that's it for the RS232, and it's closely related to the RS485. I did mention in part one that I thought we might try talking LuckFox to LuckFox, but I think we've seen enough now with this particular protocol. So that will conclude the RS232 most likely, and we'll continue with other videos on the LuckFox down the line.